Hey guys, today we're going to talk about the experimental method when you want to prove causation. Because remember, correlational studies do not prove causation. So this is kind of a long presentation, so I expect you're going to have to stop it every once in a while to take notes. But it's a really important part of what we're learning for this unit, and there's a lot of definitions in here that we need to understand, and we'll be covering some of these in class. Well, first of all, the experimental method is the only thing that you would use once you have a correlation established. If two variables are not related, you're not going to spend the time and expense conducting an experiment. Experiments will seek to establish cause and effect, and they are conducted in the most controlled environment as possible. Sometimes that's a laboratory setting, but often it cannot be in a laboratory and it's conducted in the field or outside of a laboratory. So let's take a look at these scenarios here. Would you use an experimental, whoops, sorry about that. Would you use an experimental method or would you use a correlational study? So let's take a look at this. Men are better drivers than women. People with blue eyes have worse eyesight than average. Children who live in high-income families are smarter than average. So when you conduct an experiment, you have to control the independent variable. That is the presumed cause variable. So in the first one, men are better drivers than women. The presumed cause of being a better driver is the fact that you are genetically a man. Well, can we control that? Can I actually be able to randomly assign someone to be a man or a woman? Or as in the second case, can I randomly assign someone to have blue eyes? Or can I randomly assign a child to live in a high income or a low income family? And the answer, of course, is no. In other words, we cannot conduct experiments when we are talking about things like gender, demographics, etc. Let's start, though, today. We are going to investigate a theory, and we're going to conduct an experiment to test this theory. And the theory we've selected is alcohol decreases inhibition and makes it more likely to engage in violent or aggressive acts. So we're going to use this theory to design an experiment. Now, if we're going to investigate this theory, we need to examine the relationship between alcohol, or drinking alcohol, and violence or aggressive behavior, either one. There are three initial questions we have to ask ourselves. If indeed it's true that when we see people drink alcohol that they become aggressive, is it because A, alcohol consumption caused B, aggressive behavior? Is it possible, however, that someone who has aggressive tendencies tends to be someone who also consumes alcohol? They might feel it calms them down, but they're already aggressive. But is there a third variable, a confounding variable that causes both alcohol consumption and violence, like genetics, high testosterone levels, lack of parental supervision? Let's create a hypothesis, and we're going to also create a null hypothesis. And for those of you who've taken science, you probably have seen this before, but we'll review it. A hypothesis is a testable prediction. A null hypothesis is a disconfirming hypothesis. It basically takes our hypothesis and it states that the independent variable will have no effect on the dependent variable. And because we are scientific thinkers, and because we, unfortunately, as human beings, engage in things like confirmation bias, looking to confirm the bias we already have, scientists seek to reject a null hypothesis. They cannot accept their hypothesis, but they work to reject the null hypothesis. And they can only reject the null hypothesis if the data demonstrates statistical significance. In other words, they are confident that the results they got were not due to chance. Let me explain that in the context of this experiment. In this experiment, we are going to be testing people who are not drinking alcohol and testing people who are drinking alcohol. And we're going to test their level of aggression. Now, let's say we have a numerical number that we come up with, and the level of aggression for people who don't drink alcohol was 5, and the level of aggression for people who do drink alcohol was 7. If that data is determined to be statistically significant, then we can be confident that the results were not due to chance. That difference between the 5 and the 7 was not due to chance. It was due to alcohol causing the aggression. Okay, so our hypothesis in this experiment is going to be alcohol consumption will increase violent or aggressive behavior. And the null hypothesis is that alcohol consumption will have no effect on violent or aggressive behavior. Now, I understand that my video is superimposed on top of this slide, so I'll say that again. The hypothesis is that alcohol consumption will increase violent or aggressive behavior, and the null hypothesis is that alcohol consumption will have no effect on violent or aggressive behavior. Our second step is that we need to identify the variables. We need to identify what is your independent variable. That is the experimental factor that you're going to be manipulating and whose effect we will study. And you can think of that as the cause variable. What do we think is causing another thing? So we are saying that alcohol, our independent variable, is alcohol consumption. We believe that that's causing what? Aggressive or violent behavior. So the dependent variable is the experimental factor that's being studied, and its outcome may be affected by the independent variable. And I say may because this is an experiment. We may find out at the end of the experiment that the results are not statistically significant, that we cannot reject our null hypothesis, that indeed that independent variable may actually not affect the dependent variable whatsoever. Okay, so given our hypothesis, alcohol consumption will increase violent or aggressive behavior. Our independent variable is alcohol consumption. That's something we can manipulate. The dependent variable is what we are measuring, and that's aggressive or violent behavior. Step 3 is we are going to operationally define our variables, both our independent and dependent variable. We have to explain how we're going to measure them. When I go to replicate or repeat this experiment, so that I can generalize my results to more than just the people I studied, I'm going to need to follow these procedures again, or maybe if it's not me following them, maybe it's somebody else I'm passing this off to follow them. And we need to ensure that there is inter-rater or test-retest reliability. Remember, reliability means consistency. So we need to operationalize things such that they are quantifiable, and there's no, gray area in them. So we'll do our best. And for this experiment, we're choosing to define alcohol consumption as blood alcohol content of at least 0.02. Okay? Now, the dependent variable is a little bit harder because I have to decide how am I going to measure aggressive or violent behavior. So in this experiment, I'm choosing to put participants that drink alcohol and those that are not drinking the alcohol into a situation where they are given a paintball gun. And that paintball gun has different velocity settings. And there's going to be one for low, one for medium, and one for high. And then they're going to be given a human target to shoot that paintball gun at. Okay. And I'm going to operationally define aggression or violent behavior as when the participant selects the high velocity on the paintball gun. Now, is that a perfect and valid definition of aggression? It's probably relatively valid. It's not perfect, but that's what experiments are. We do our best to try to measure that dependent variable, and it's in somewhat of a false situation here. Now, we have talked about the fact that alcohol could be causing violent behavior, and we're going to administer the alcohol first, so we know that's going to come first. But what about that third variable, that confounding variable, that extraneous variable? Those are all 3 terms used to discuss a factor other than the independent variable that could cause a change to the dependent variable. And when it comes to aggressive behavior and drinking alcohol, there are other things that could cause someone to be violent other than alcohol. It could be that somebody has a violent-prone personality, and that violent-prone personality leads them to both drink alcohol and engage in aggression. They might have abnormally high testosterone, and that increases stress and anxiety, so they seek alcohol to lower that, but they're also violent because testosterone causes violence. They might have had a recent exposure to a stressful event, and that could cause them to drink to, again, try to de-stress or relieve that stress. But that exposure to a stressful event can also increase hormone levels that would cause them to be violent. But the last thing that we also need to worry about are things like being encouraged by the experimenter. Let's say the experimenter hands them that paintball gun. They're like, hey, you can turn this paintball gun to low, to medium, but you can also turn it to high. And when they say that, it kind of encourages the person, the participant, to be aggressive. So these are all confounding variables that we need to both identify and then try to mitigate or attenuate. We need to make sure we can handle them and make sure they're not going to hurt our experiment. Okay, we're going to identify the population and we're going to obtain a sample. Now, before we get to that in our experiment, there are a lot of definitions here that you need to know. The population, we usually refer to it as N, big N, is the group of people we're studying. And we're going to select a representative sample from that population to become participants, which we are also called samples, but that's little n. So population is the large group of people we're studying. Are we going to include every single one of them in our study? That's impossible. I'm studying high school students in the United States. I'm not including everybody, but that is my population. And I will randomly select a representative sample. Now that sample, again, also, these are the people chosen from the population to participate in the research. We sometimes call them participants. But that sample you might see is referred to as little n. So our big N is our population and our little n is the sample we've selected to participate. Now, how do we get those participants? Well, you have to make sure that you select your sample from your population such that each person or every person in the population has an equal chance of being selected. That is something you need to write down. It's really important. Random sampling, random selection means that everyone has an equal chance of being selected. And the method that you use is going to vary. It will depend on who your population is. And we'll talk about that in the context of our experiment. The reason we do this is that we want to eliminate sampling bias. And that can result when a researcher uses what we might call an opportunity sample. A lot of researchers are researchers at universities. So they use, if they're looking at children, they might use children of professors. Well, children of professors probably are in a high socioeconomic background. They have a high inherited level of intelligence, likely, and they grow up in a very similar environment to the other children of professors. So that opportunity sample might mean that there's a sampling bias. So by doing a random sample, we try to eliminate that sampling bias. So when you're ready, you can pause the video if you haven't finished writing down these definitions, and we're going to move on. Okay, so whoops, I don't know what I just did here. I'm going to go back. Okay, so we are going to, in this case, we're going to identify the population, obtain a sample, and our population is, I'm choosing the University of Maryland senior student body because they're over the age of 21. And if they're not, I'm defining it as over the age of 21 because they can drink alcohol. And the way I'm going to select them randomly is that I'm going to use a random number generator. So the word that's hiding underneath my picture is the word number. So selection will be made using a random number generator of student IDs. Now, by doing that, every person in my population has an equal chance of being selected. Okay. At this point, we're going to establish our control and our experimental groups. Now, a control group. A control group is the group that is not going to be exposed to the independent variable. Often, but not always, control groups are given a placebo. That is a substance that has no therapeutic effect. Some people think of it as a sugar pill, and sometimes it is a sugar pill if you're studying a drug. But this group is your baseline so that you can compare it to those people who are exposed to the independent variable. Now, experimental groups are the exact opposite. These are the groups that are going to be exposed to some form of the independent variable. Okay. In the context of our experiment, in our control group, I'm going to give our participants non-alcoholic wine or beer. And in my experimental group, I'm going to give them alcohol such that for one of the groups, their alcohol content is going to be measured at 0.08. And for another group, the blood alcohol content will be measured at 0.05. So Sometimes researchers make use of multiple experimental groups because they might find that aggression levels are not so high at 0.05, but are super high at 0.08. Okay, so just wanted to show you an example of how we can use multiple experimental groups. I'm going to caution that a lot of you, when you design your own experiment, which you're going to do in class together, like in small groups, a lot of people want to create a baseline. They want to say, okay, drinking caffeine makes a person run faster. And then what they do is they say, well, I'm going to have a group of people and I'm going to see how fast they run. And then I'm going to give them caffeine and I'm going to see how fast they run. I'm going to see if there's an improvement. Well, that's fine, but that's not an experiment, because in an experiment, your baseline is the control group. So if you were conducting an experiment like that, you wouldn't measure people before and after caffeine. You would measure people who did not get caffeine, and you would measure people who did get caffeine, and you compare those results. Okay? Okay, let's take a look at step 6. We're still actually on step 6. So we're talking about the control and the experimental groups. So participants in that control group are going to be given a placebo. And the placebo I'm giving them, as you noticed for my control group conditions, was non-alcoholic beer and wine. But because it will taste like beer and taste like wine, they might be subject to what we call the placebo effect. So researchers use placebos during studies, and they try to help them understand what effect a new drug or some other treatment might have on a condition. So in this experiment, none of the people who are in the study are going to know if they get the real treatment or the placebo. Hopefully they won't know, because I'm just giving them stuff that tastes like wine or beer but doesn't have any alcohol in it. And then the researchers will compare the effects of the alcohol and the placebo on the people in the study, and they'll determine whether or not alcohol increases violent or aggressive behavior. So what is the placebo effect? Well, sometimes a person can have a response to a placebo. The placebo can be positive or it can be negative. And in this experiment, a person may feel high. They might feel high because they think they had alcohol. And so what it appears to me is that they have side effects from the treatment, and that side effect is known as the placebo effect. So when a participant has what appears to be a side effect from the treatment, it's known as the placebo effect. And I know my picture's covering that up. So again, when a participant or a person has what appears to be a side effect from the treatment, that is the placebo effect. Okay, let's take a little look now at how we're going to get people. We're still on step 6, but we have to get people into the control group and the experimental groups. And we want to make sure that confounding variables, those third variables we talked about, like having violent prone personalities or being having just experienced a stressful event, that those things don't actually muddle up our experiment. We want to make sure that those are not the things that cause us to see changes in our dependent variable. So let's just assume I have 100 people and they're part of my participant. Those are my sample, my participants. And out of those 100 people, I have 3 people who have violent prone personalities. Now, I don't know who they are. So when I go to put them into a control group or one of my 2 experimental groups, I'm hoping that those 3 people will be evenly distributed. In other words, one will end up in the control group, one will end up in experimental group A, and one will end up in experimental group B. Now, I can't make sure of that, but I can use a procedure called random assignment to make sure that's statistically as likely to happen as possible. So random assignment, not to be confused with random selection, because random selection is when we select our sample from the population. Random assignment is when we take our sample, now that we have our sample, and we use a procedure to assign those sample groups, sample participants, to the group so that each participant has an equal chance of being in any one of the groups. Well, how do I achieve random assignment? Well, I achieved random selection by randomly selecting student IDs out of a database at University of Maryland. With random assignment, and usually participants in an experiment are given a participant number, and that number is stored along with their name in a database. And then a random number generator is used to assign participants to one of the experimental groups or the control group. So that random number generator is like picking names out of a hat, okay? But it's an electronic form of doing that. So it's going to be your best friend every time you run an experiment. To achieve randomness, you're going to have to use some kind of a random number generator, which means you have to assign participants or a number. Okay, by doing so, we're hoping statistically that those 3 people that have violent prone personalities will be distributed equally throughout our groups. Now, it's just not violent prone personalities that we're concerned about. There's lots of confounding variables, and there's going to be a whole number of people who have confounding variables. And again, using random assignment, we hope that those people with confounding variables are going to end up in different groups, and it won't really affect our experiment. So just to see what it looks like, let's start with our population at the top. We randomly select from that population to achieve a sample. And then from that sample, those are our participants, we will randomly assign them to a control group or the treatment, or otherwise known as the experimental group. And our experiment, we have 2 of them, 2 experimental groups. So we need to be concerned about internal validity. Remember, validity is accuracy. When we talk about internal validity, it's the extent to which we are certain that it's the independent variable that caused the changes to the dependent variable. In the example I gave earlier, when I measure people in my control group, I might find that there's a 5% of them actually engage in turning that paintball gun up to the highest level. But 7% of them in my experimental group changed the paintball velocity up to the highest level. So I want to make sure that the reason that number is 7 in my experimental group is because they drank alcohol. In other words, that's the extent to which I can be sure that alcohol, which is my independent variable, caused the changes in my dependent variable, caused that group to have a higher percent chance of choosing that high velocity level. So there are a few things that can go wrong that can threaten our internal validity. And we've already talked about one of them, which are extraneous or confounding variables. But there's also something called experimenter bias. And that's when the scientists who are performing the research can influence the results in order to portray a certain outcome. And I also discuss this when I'm the experimenter and I hand one of my participants who just drank alcohol, and I know they drank alcohol, and I hand them a paintball gun, and I say, you can turn this up to the highest velocity you want to. But when I hand that same paintball gun to somebody who had the placebo, I say, you can turn the velocity up as high as you want to. My tone of voice is different, and it could elicit a different response. So that's called experimenter bias. There's also experimental demand, and that's when the hypothesis of the experiment is apparent to the subjects, to the participants, and then they try to comply. They say, oh, I know I drank alcohol, therefore they probably and gave me a gun, they probably want me to be aggressive. I'm just going to go ahead and turn that paintball gun up. So we have 3 issues that we have to deal with that can threaten internal validity. And how are we going to deal with them? Well, we already dealt with the extraneous or the confounding variables. We use random assignment. Now, when it comes to experimenter bias, what if I, as the researcher or the experimenter, had no idea, if the participants were in the experimental group or the control group? That's important, because if I don't know, I'm probably not going to change how I hand them that gun and the instructions I give them. So a double-blind procedure is when neither the participants nor the experimenters know who is receiving a particular treatment, and that's supposed to reduce bias. Now, sometimes it's not possible for the experimenter to not know who's in what group. I mean, if they're giving medicine, sometimes it's hard to do. And sometimes the only thing you can do to handle the idea of experimental demand, in other words, that the participant tries to comply with the hypothesis, is to use a single-blind procedure. In a single-blind, the study consists of subjects or participants who are unaware if they are part of a control group or the experimental group. Okay, so these are the 3 threats to internal validity, and these are the ways we can reduce the effects of these threats. Step 7 is replication, and replication ensures that our results, we actually will repeat the experiment to ensure that our results would hold true if I conducted the experiment at different places, at different times, and with different people. And in order to generalize my results to my population, I must replicate or repeat that experiment. And of course, replication is only possible if you have good, strong, quantifiable, valid operational definitions. That way you can make sure you have consistency, that inter-rater reliability that is so necessary for internal validity. Now, again, my face is covering it up, but just reminding you what we talked about earlier. Validity requires reliability. I need my experiment to be internally valid so I can make a causal statement. So I can say that the alcohol consumption causes violent behavior. If I don't have internal validity, I can't do that. I can't have validity unless I have reliability. So hence why operational definitions are so important, because operational definitions give us a consistency from one experiment to another. Okay, so we're pretty much done with this presentation, but I realized I missed a slide. So if you're actually going back to the slideshow, it's slide 11. But in this slide, what we have is a example of a hypothesis and how it applies to population and sampling, et cetera. So I would encourage you to go back and take a look at slide 9 if you're still not quite, slide 11, if you're still not quite sure about how population works with random sampling and how sampling can help us to infer our hypothesis to the population. So go ahead and do that. Anyway, that's it for this presentation. We are going to be doing some work together as a class, and I will see you there.